Hello, we're in Energy 101. I'm Dr. Sam Shelton at Georgia Tech, and this is the section that looks at energy sources. We saw that the energy that we use in society comes from various sources. We talked about coal, where 20% of energy comes from. We talked about natural gas, that supplies 26% of our energy. And today we're going to talk about oil, which supplies 36% of energy. It's the biggest single source for the energy that we use in our society. And we'll see that that's linked to transportation. Nuclear provides 9% of the nuclear power plants that produce electricity. Biomass is ethanol, as well as biomass waste from things like pulp and paper mills that burn it to help supply the steam and electricity to them. Hydropower, the dams that we generate electricity from, is about 3%. Wind is about 1.2%. Geothermal is 1/4%, and solar is about 1/10%. So that's where all the energy comes from, just a quick review. And today we're going to talk about the biggest one, oil, 36%. So where does the oil go? What sectors consume that oil? Well, as I already mentioned, transportation is the dominant one. Manufacturing uses 23% of it, and that we don't generally burn the oil in manufacturing to make things that we want to buy. We generally are using the molecule, for instance, making plastics and making chemicals. So manufacturing is the number 2 utilizer of oil. Residential is about 3%, and that's essentially space heating in the Northeast, where they have no natural gas pipelines down the street, and they have to use oil or maybe propane, and it's cost them significantly more money than natural gas would if they had natural gas pipeline down the street, but they have no alternative to get natural gas in that area. And electric heat pumps are a problem because they don't have a duct system with air conditioning. That's the whole technical detail there that we get into later. Commercial sector, buildings, 1.6%, and then electricity is 0.5%. Don't miss that electricity. The electricity is an important point in that only 0.5% of our oil is used by electricity. So that will have an important implication here as we go through that we'll see. Oil was not first, but basically the massive discovery of oil was in the Spindletop area in Texas in 1901. We actually started using oil with the advent of the invention of the internal combustion engine and the automobile in the mid to late 1800s. But we didn't really start drilling and getting oil from beneath the ground in deep wells until 1901. And there's a shot taken in 1901 of that well down in Spindletop, Texas. Just like the other hydrocarbons, coal and natural gas, you burn it. We don't need to dwell on this. You notice the chemical formula is a little bit more complex. You don't need to learn this or memorize it or anything, but it's a little bit different in that it's got an unknown called N. Oil is generally designated by CnH2n plus 2. N can be 1, 2, 3, 4. N is an integer, depending on the length of the molecule and the heaviness of the oil. So you can then react it with oxygen, but you need 2 N oxygen molecules to react with the carbon and hydrogen that comes with that oil, and it goes to NCO2 molecules and N+1 water molecules. So again, oxygen is reacted with carbon and hydrogen to produce CO2 and water in the same way that natural gas and coal is. So of course coal has no hydrogen. But in the process it produces heat, and the reason for that is the chemical energy in the molecules on the right-hand side of that equation, the CO2 and H2O, is less than the chemical energy in the hydrocarbon molecule and the oxygen. So we're decreasing the chemical energy content and converting it into what we call thermal energy or heat. And that's what combustion is all about, that conversion process from chemical to heat. Oil consumption. So how much do we use and what's the trend? Well, here it shows it from the 1900s, then from when Spindletop was first drilled and came in, and oil, Texas, by the way, has been the largest producer of oil of any state in the Union ever since, and still today, by a significant margin. But it increased, and it dramatically increased in the 60s and 70s. You notice it topped out in the late 70s. You might think back of why that might have been the case. There were two reasons, number one, we had the embargo, oil embargo, and so that scared the heck out of everybody, and everybody that could quickly get off oil and convert to something else and use something else did so, just for stability and reliability. But the other reason is electric power. You noticed that only 0.5% of oil is used for electric power. That was a much higher percentage in 1970, much higher percentage. So we burned a lot of oil in power plants to produce electricity in the early 1970s, building up. But then oil became so expensive when the oil increased from about $2 a barrel to approximately $10 a barrel in the 70s. That's a five-fold increase. That's higher than probably, if you stop and think about it, that you've ever seen. Five-fold increase. So it was a dramatic impact on our country, and anybody that could get off oil got off oil. It was the first implementation of car mileage standards by EPA, by the government, and to force higher fuel efficiency, which has been continually going up. It was stable for about 20 or 30 years, from 1980 to 2010, essentially. But now it's scheduled to go up to around 50 miles per gallon from the 28 or 30 or so in year 2025. So there are lots of reasons why the oil consumption declined. And then it started increasing again once we got off the easy oil to get off of, electric power plants and other uses that just made the cost made oil too expensive, with a dramatic increase, and for reliability reasons. You see it's been flat since about 2007, that 2008. That obviously has everything to do with the recession. Again, we saw earlier that when the economy drops, the gross domestic product, and a recession comes, then you have a decrease in energy consumption, and oil is one of those things that get hit. So, and now we're starting to move up again as the recession, we're coming out of the recession, as you see, from 2009 or so. That data is through 2011, by the way. So that's our consumption side. So where is that oil coming from? We've got to get it from somewhere. Where is the oil coming from? Well, here's showing our production, U.S. oil production. And this has got some interesting aspects to it. We could spend a long time on this slide, but let's just look at the major features. Again, it starts at year 1900, and we're talking about millions of barrels per day, by the way, on the vertical scale, as we did on the previous slide. We see that's millions of barrels per day on the vertical scale, 2, 4, 6, 8, 10, 12, 14, 16 million barrels per day. And here, same way. So from 1900 to 2011 also. So this is our U.S. oil production. The yellow area is our lower 48 state oil production, and the purple is our Alaska production. You notice that the Alaska production came in a little bit in the mid-70s and really boomed with the North Slope discovery in the 80s and development of that. They built the Alaskan pipeline to get that oil down to the U.S. And it maxed out in the mid-80s to late 80s and has been declining as every oil field does. When you drill a well, the production declines at about 4% per year. So your maximum production is going to be the first year that it's in production, and then its capability to produce oil or extract oil declines every year. So you got to keep running in order to stand still, because we have to find enough new oil coming out of new wells that we drill in order to make up for the declining production in the existing wells. The major feature that you might find surprising here is that oil production in this country peaked in 1970. Peaked in 1970. What was the price of oil in 1970? It was $2 a barrel. $2 a barrel in 1970. Oil production peaked, and we have never reached that peak again. In the mid-'80s, we came closest to it because of the North Slope Alaskan oil production coming down the Alaska pipeline. But it declined then up until about 2008 when it started climbing again, and that's been primarily North Dakota, and this is all U.S. produced oil. So we have had an increase, as we've had some in the past. It's not a nice smooth curve. It hasn't continued to decline since 1970, but we're seeing a bump up at this point. So where's the rest of it come from? Because that does not meet our consumption. The red area shows the difference between our production and our consumption. The red area is obviously then our imports. That is the oil that we're importing. We're currently importing about 60% of our crude oil, 60%. You hear lots of different numbers, but in crude oil, we're importing about 60% of our oil, give or take a few percent. This is data right out of the EIA, as I've noted there. That's the Energy Information Agency, part of DOE, and it was formed in the late 70s to keep up with oil and energy facts in general, and is a good, reliable source for energy data. So that red area has generally been increasing, but it's hard to tell on this scale about what the trend has been. But let's look at the next slide that shows just the oil imports. You notice again the oil imports peaked in the late 70s, just about the time we had the oil embargo and the sharp price increase to about, we were importing about 6 million barrels per day. And then with the price quadrupling and the availability with the interruption of the supply from the Middle East, it dropped the imports down to close to 3 million barrels a day. So it cut it in half. But that, as I already mentioned, that was because we started using less oil, but we didn't, and we primarily took care of the drop in the oil use by decreasing our imports, which would be naturally the case. And it's been climbing since. It declined again in 2007, primarily again with the drop in recession because our demand went down and our increased production. So that's our trend on oil imports from 1900 to 2011. So where's the oil going? Again, the oil is going to 72% of it is going to transportation, 23% to manufacturing, 3% the residential, but the key number is 0.5% for electricity. So the conclusions from all of this is the U.S. is dependent on imported oil. You just can't get away from it. When you're importing 60% of your oil that you used, you are dependent on imported oil and all the implications for that. But the other thing that if you look back against the information we talked about in coal and gas, we essentially supply and produce all of the coal that we use and all of the gas that we use. The only exception is the gas, natural gas, in which we get 15% of the gas or 14% of our gas from Canada. So we are essentially energy independent on coal and gas, but we are not energy independent on oil. There's a big distinction. All energy is not created equal. You can't just go around throwing a chunk of coal in your gas tank in your car and drive your car on a chunk of coal. And running on natural gas has lots of problems and issues and cost and economics also. So what that means is coal and gas is the electric power fuel resource. And again, reinforces the fact that we do not get any of our electricity from oil of any significant amount, that it being about 0.5%. There are for some unique reasons that probably is not going to change anytime soon. So that's where our oil is coming from and how we're using it, and we'll talk about pricing, energy pricing next time, talking about why is it that Europe pays $8 or $9 a gallon for gasoline and we only pay $3.50 to $4. What's the pricing issue here, and how is the price of oil determined for us and other countries in the world? Thank you.